Click now. So, not much surprise that the last lesson was exponential equations. So now we're going to have a look at logs. Oh, write that in here, sorry. Logarithmic equations. Equations with log. So again, there's no new formulas. We are just going to use the formulas we already have to solve problems with logs in the equation. So let's start off with a simple example to start with. Right, so for logs, it's very important that you say when it is defined. So at the start of the question, you must say what values can the x be. So in this one, what could the x be? Could it be any number? Could it be any number? The x. No, it can't be any number. What number can it not be? Can't be negative, and it can't be 0. So at the very beginning, you must say x should be positive. Then, after you do that, you can solve. Now, this question here, there's not really anything to solve. You just need to think. What number do I put here to make the answer 1? There's only one number. 7. If I write 7 here, then it's right. 7 to what power makes 7? The answer is 7 to the power of 1 makes 7. So the answer here is x equals 7. So there's not really anything to solve. What I want you to learn in this question is the importance of saying this at the start before you start. You must do that for these questions. It's very important. Okay, so we'll move on to something a little bit different then. So write this one down. How's my battery doing? It's okay. You got it? Got it? Who's disgusting? Okay, got this? Yes. Okay, so what about something like this, for example? 5 power x equals 4. Now we can't do what we did last time because it's a 5 and it's a 4. We can't do that. And some people don't have this option on their calculator where they can change the base 5 to what power makes 4. But everybody has this on their calculator. Everybody does. So what you can do here is you can put log on both sides. Now before I start, let me just say that x can be any real number. Okay. So you have log on the left, log on the right. So here I can use, what is it, the fourth rule of powers? This x, I can bring it down in front. So I get x log 5 equals log 4. So x equals log 4 over log 5, which is 0 point something, I guess. 0.861. So everybody has ln on their calculator, so you can solve it this way.
Can you look 10 as well?
Yep, yep. In fact, n base, yeah. So there should be at least one log button on your calculator.
Yes,
Yeah. Okay, we get the idea here?
yeah.
Let's do one that's like this, but a bit more difficult. Can I scroll down? Yes? Okay, so for example, 4 power 7x minus 7 equals 7 power minus 3x minus 6. And again, x could be any real number. So I'll just say these ones are pretty common in the exam. I mean the final exam. The last two were too easy. This is like the first exam difficulty question we have. Okay. So the trick here is the same. You put log on both sides. So you have log 4 power 7x minus 7 equals log 7 power minus 3x minus 6. And again, you bring the powers down, but be very careful. These should be in brackets to make it a little bit easier. So you get 7x minus 7 log 4 equals minus 3x minus 6 log 7. Yep. Next step, we should multiply the log 4 on both, and here we should multiply the log 7 on both. So here we get 7 log 4 x minus 7 log 4 equals minus 3 log 7 x minus 6 log 7. So you can see that you have an x here and an x here, a non-x here and a non-x here. Yeah. I opened the brackets there. Or distributed, as you say. Yes. Wait, did they Australia distributed? Expand, okay. Okay, good. Good. Right. So I'll take the x's to the left and the non-x's to the right. So on the left I have 7 log 4 x plus 6 log 7 x equals what? Yeah, exactly. What? Plus 3 log 7 x equals 7 log 4 minus 6 log 7. So this one came to the left and this one came to the right. Okay? Yes? What can I do on the left? Take x out. Yeah. So you can have 7 log 4 plus 3 log 7 x equals 7 log 4 minus 6 log 7. So there's only one step left. We have to bring the logs down. So this would be x equals 7 log 4 minus 6 log 7 over 7 log 4 plus 3 log 7. So we'll hit that in and see what we get. minus 0.127. A little difficult, but common for the exam. Is that right? No?
Yeah, it's okay.
It's okay? Yeah.
Does it say? Yeah.
Let's double check. Oh yeah, I rounded a bit more. Oh, the question says 2 decimal places. So I should really say minus 0.13. Okay? What's wrong?
I think you calculated this in.
Think carefully about what you're going to say. You're going to say the calculator doesn't want to do this one. Show me what you typed in. Show me. No close brackets.
Yeah, the bracket is it after the four or
It is.
and then another open bracket?
No, you just forgot a close bracket, that's all. Okay. Next one, do you have this? Yep. Okay, so next one now. 9e power 2x minus 3e power x minus 6 equals 0. Yes? Yes? This is also common for the exam. I don't think can we factorize here because it's like a quadratic. It's like 9ex squared minus 3ex minus 6 equals 0.
Choose the formula.
We can just use the formula, but does it have factors? It actually does have factors, but you can use the formula if you want. So if you use the formula with a equals 9, b equals minus 3, and c equals minus 6, you get two answers. You get 1 or minus 2 over 3. What equals 1? Is it x equals 1? No, it's e, yeah. It's e power x equals 1 or e power x equals minus 2 over 3. Yeah? Now, here x equals log 1 and here x equals log minus 2 over 3. But you see, one of these is wrong. Which one? Yeah, this one actually has no answer. Impossible. Can't make it minus. So you only have the answer here. X equals 0. Okay? Yes? This is okay? It's a little like the last lesson as well. Can I go down?
Yes.
Continue? Yeah. Okay. Now, in fact, whenever you have terms like this with x in the power, it's always possible to write this in the form of a, e, k, x, where a and k are constants. And in fact, it's for many math problems, it's much more convenient to have things like this written in this form. Much more convenient. So for example, for those people who've studied calculus before, some people have seen this. Yeah.
Yes.
Not everybody I know, but some people have seen it before. So you can calculate it here, but you can't do it for this one. Yes? See, they're laughing because of fear. They remember it, yes? Yes.
You have to study this.
Yeah. Sorry to break this to you. So anyway, there's many other reasons as well. Like for example, when it's in this form, you can use ln on your calculator. When it's in this form, you know what the graph looks like, and so on and so on. So we want to learn how can we rewrite it. Okay, have you got this? Right, so the first thing I'm going to do is I'm going to separate on the top. So here I'll change this into 2 power minus 9x times 2 power 4. So this is starting to be like the constant that's in the front. So I'll just write it the other way. By the way, what is 2 power 4? 16, isn't it? So this is 16 times 2 power minus 9x. So far we think this is maybe the a that's in front, but this, we need to do something here. So I'll just go to the side for one moment. I'll go back to this. Log base ex. What does that equal? It's x, because e to the power of x makes e power x. So in other words, log ex equals x. You can cancel the log and the e to just be left with x. And you can also write it the other way as well. You can write e log x. What will that equal? Again, that will also equal x, because e and log can cancel. So if you want to think about it like this, you can write down log ex equals e log x, which equals x. That whenever you have a log and an e, they can cancel to leave x. If you didn't know that, write this down, because this will be useful for the next part. Yes? Continue? Yeah? Not yet? Continue? Okay, so we'll go back here, and what I'll do now is I'll write this as 16 times 2 minus 9x. There's nothing interesting there. But now I'll use my trick from the left. I'll change this into e log 2 minus 9x. Now, it might help if you think of the 2 minus 9 as one number. Here it is here. So I just put in the e and the log. I can do this because e and log cancel, so I'm still left with the 2 power minus 9. But the reason I did that is so I can make an e. Now you know that if you have a power here, you can bring it down in the front. This minus 9 goes in front of the log. And then next, you can change the top to multiply the x. So I just multiply the x by this number. Now I'll get what that number is. Minus 9 log 2 that's e power minus 6.2383x. So you could test this on your calculator. You could pick a number for x, for example 5. if you put x equals 5 in here, and if you put x equals 5 in here, you should and you will get the same answer. Now it won't be exactly the same because I had to round here. In fact, this answer is more accurate, but they'll be the same. So I found the A and the K.
Excuse me?
Yeah.
I didn't understand the formula.
Which one? Which formula? Which step?
The fourth step?
1, 2, 3. Here?
Yeah.
Yeah, so there's a little trick here. If you can check this on your calculator. If you have a number like whatever, 5, you can write that as e log 5. If you type in e log 5 on the calculator, you still get 5. Check it. Yeah. It's a bit like when you change, for example, if I change 5 into square root 25, I put in a square and a square root, nothing changes. I put in an e and a log, nothing changes. So e and log, they're like opposites, like square and square root. Yeah?
Yeah, why is that LS2 and the sign?
This step here?
No, above. Yeah.
Oh, I was literally answering his question. You just asked me the same question he asked me, which I was answering when you interrupted me. So, yeah. Do I want to repeat myself? There's time to repeat myself. So, on the side here, if I have 5, you can type in on the calculator e log 5 and you will get the same answer. It will still be 5. Just like if you had 5, you can write it as square root 5 squared. Square and square root cancel, e and log cancel. They are opposites. So if I have 2 power minus 9, I can write that as e power log 2 minus 9. This is just a number, like 5. It's the same idea. Would anybody like me to repeat it for a third time? Or twice is okay? Twice is okay, alright. Actually, I do wonder what I get if I type 5 in, since I've said it so many times. So, minus 6.2383. It's a tiny number, isn't it? Yeah, it's a tiny number. 4.5, 10 to the minus 13. Look, hey, let's let's do a simple example. So if I put x is 0 in here at the start, what do I get here if x is 0? Look up. 16. Yeah? And here if I put x is 0 at the end, what do I get?
0.
So in total, it's 16.
16.
Same answer. It'll be the same for all values of x. This is something useful in the exam and in your project as well. I sense lots of confusion. Confusion? Questions? No? We're okay? You don't look okay. You're okay? We think so? Okay. Next example then. Can I scroll down? Yep. Okay. Right, so now more difficult ones. So I have minus 7 log 2x plus log x8 equals minus 6. Yeah. Write this down. Okay, so before I start, it's very important to say what values x could be here. So could x be any number in this one? What's it look like? Can't be negative, can't be 0. So, and in fact, maybe this makes me think it should be more than 1, but I'm not worried about that. This one here tells me x must be positive. So if I get a negative answer, I can't use it. Okay. So what could I do first here? You see, the first problem is that this base is 2 and this base is not. Not only that, here the x is not in the base and here the x is in the base. So first thing, deal with the base. But I noticed something that's going to happen. I could swap the x and the 8, and then what happens to the log? What do I do? If I swap x and 8, what happens to the log? It gets flipped upside down. Yeah? So I mean, you could change this into 1 over log base 8x. But that just makes a new problem. That the base here is 8, and what's the other base? 2. So before I do that, I'm going to change the 8 into 2 cubed. Now, what do you think I should do next? Not yet. Bring the power down. Yeah. So here I get minus 7 log 2x plus 3 log x2 equals minus 6. Yeah. Now I can swap. So here I get minus 7 log 2x plus 3 times 1 over log 2x equals minus 6. What could I do next? So the problem here is the log is in the denominator down below. What could I do next? I could multiply everything by the log, yeah. So if I did that, I would get minus 7 log 2x all squared plus 3 equals minus 6 log 2x. If I multiply everything by log, this will be log by log, log squared, log and log cancel, log at the end here. Multiply everything by log. Now before I continue, I need to say something here. Some people will make this mistake, so let me make it clear now. This here is not the same as this. They're two different things, okay? On the left, this is log bx times log bx. But on the right, this is log b of x times x. So you can see they are different. So don't make that mistake. So this 2 does not go down. It stays in the power, the 2. Okay, what can I do next? It's looking like a quadratic, isn't it? So I think I'll bring everything to the right. So I get 7 log 2x squared minus 6 log 2x minus 3 equals 0. Now I don't think this has factors. I took everything to the right, so this becomes plus, minus, and still minus, yeah. Yeah. Now, this does not have factors, so we just use the formula, and we get 2 answers. My first answer is 1.211, and my second answer is minus 0.3539. Now that's not for x, that's for the log 2x, because that's like the x in the quadratic. So I have log 2x equals and log 2x equals. So finding the x is actually quite easy now, because you just need to remember what log means. 2 to what power makes x? Well, 2 to the power of 1.211 is supposed to make x. 2 to what power makes x? Well, 2 to the power of minus 0.3539, that's supposed to make x. So you get x equals 2 power 1.211. So this one here is 2.315, and this one here, yeah, what was it?
2.4.
No, I got a smaller number than that. 0.7825 about. Well, actually, in the exam, they would want it 3 significant figures: 2.32, 0.783. What's wrong? Question?
No, for the first one, you got 2.44 instead of 2.32.
Oh, okay, I'll just double check what I typed in. 2 power 1.211. Yeah.
No, it's okay. Yeah, it's right, it's right.
Yeah.
2.314, sorry.
Yeah, yeah.
It's right.
Okay, write this down. So you do get these in the exam, but because these are a little bit more difficult, they would be in section B. The other questions could be in section A. Okay. Can you mark these questions, and then I'll talk about the project. So, hey, come on. Hey. Dudes in the center, come on. Page 52. So, in number 1 to 5, you can just do the last two. TU, TU, YZ, HI, HI. But in the last question, number 6, you want to see TUVZ. TUVZ. Now let me just talk a little bit about the project. You all got the page. Wait, no, don't pack up yet. Just listen for a moment. Now, the project, you all got the page in Donald's class before the break. Yeah. And if you have it now, you can take it out to have a look at it. But this lesson now means you have enough maths done to start the project. So you have 2 weeks from today to do the project. 2 weeks. Now, what's important about... What's wrong? Okay? Yeah. Some important things to note about the project. So firstly, each student gets a different set of numbers. So if you had it here, I see some people have got the numbers already. Each person, yeah, it says the first point I think it says is, or the second point, you have been given 6 terms on Moodle. So if everybody goes to the Moodle page, there's a link called Coursework 1. If you click this link and enter your student number, then you'll get your 6 numbers. Yeah? Yeah? Each person will get 6 different numbers. So of course, you can help each other, but there's no opportunity for you to use other people's answers, because everybody will get 6 different answers. You see, I'm smart like that. Because I know what will happen. If I give everyone the same maths problem, everyone will share the answer.
It's difficult for you to correct it.
Don't underestimate me. I can do it, okay? Second thing you need to know, it is mostly a maths project, of course, but you do need to write a little bit in it. So for the first point, I tell you what to write as a kind of introduction. So there's an introduction I want to see, and a conclusion at the end. But as you're going through the calculation, it's important that you explain your steps. Like a book, you would say, okay, for example, we can solve these 2 equations by using the elimination method, or something like this, okay? So I don't want just maths. What I want is an introduction, the maths, and a conclusion. And in the maths, there should be English going along. You get marks for this, okay? Now, the important thing is that you start soon, because then when you get problems, you can ask me about it, and I can help you, and so on. There are no drafts. No drafts. No drafts. You must realize that. It means when you submit, that's the final submission. So it is important that you get help over the next 2 weeks. You can get help from people in class, from me, or from the other maths teachers. Okay? So everybody has this. So the first job you need to do is get your 6 numbers from Moodle. Then you can get started. Okay? All right. Any questions? Just talk to me about it.